Welcome to the Neural Implant Podcast, where we talk with the people behind the current events and breakthroughs in brain implants in an understandable way, helping bring together various fields involved in neuroprosthetics. Here is your host, Laden Yurachek.
Hello, everyone, and welcome to the Neural Implant Podcast. Today's guest is Professor Jin Lee. She's an associate professor of neurology, neurological sciences at Stanford, and also founded LVIS, which analyzes, debugs, and manipulates brain circuits. So it is a software as a medical device. Very interesting stuff. And Dr. Lee, do you want to introduce yourself better than I just did?
Hi, my name is Jin Lee. Thank you for having me here today. I am, as introduced, a professor at Stanford. I'm also the founder of LVIS, which takes technology that we've developed over the past 15 years at Stanford University and translates them into a clinical solution. I'm also a founder of Novera Brain Health Institute, where the technology that has now been developed through LVIS is being practiced, put into actual clinical practice, where we provide brain healthcare solutions.
Okay, so what kind of solutions are these, and what kind of data are you guys sucking up and then putting into the machine learning algorithm?
So the main idea behind what we do is that in order to diagnose and treat brain disorders, you really need to be able to see how the signal flows in the brain, which has been a very difficult problem to solve over the past many decades. But what we have really focused on is to try to get a whole brain level circuit mechanism models, and that's what we have done at Stanford. Our approach is not based on machine learning, but rather based on in-depth understanding of how the brain circuit functions. And we draw insight from the 15 years of research where we try to understand for a certain disease what kind of circuits are activated to be able to have certain behavior. What are the normal circuit functions and how are they broken in disorders? And so based on those insights, we built a clinical solution at LVIS, and the solution is called NeuroMatch. The idea is that we match individual brain status with the visualization of the network function. And so to deliver this in a very practical manner, we made a solution. Our first solution at LVIS is to develop a technology that can be delivered through EEG measurements. And so it's not based on machine learning, but what we do is to draw insights and then put it into an EEG solution in software where we visualize your brain network status.
Wow, very cool. So you're just putting on the EEG cap and you're able to predict epilepsy or Alzheimer's, and then what kind of correlation or how accurate is it?
That's a great question. What we have done over the past decade that LVIS has been in existence was to put together a solution that could very easily deliver some of these solutions. We had to make a lot of different developments. Two key areas that we tried to solve. One is the accessibility issue. And second is also accessibility issue in a way where we try to solve the interpretability. So with the full software solution, we can easily clean the data and have a way to look at this data. And epilepsy is one very key indication that we worked on, but also it is able to find, we generally look at the signal balance in the brain and with then visualize detail network activity. And epilepsy, memory problems, traumatic brain injury, anxiety, depression, sleep, anger management, empathy are some of the issues that we've been able to directly visualize in individual patients. And it's very exciting to see that actually we can see these information as the symptoms come and go. And so we are currently conducting more studies to define the numbers of how accurate it is. But from what we can tell, we can see the symptoms come and go in individual patients with quite significant accuracy. And it's very exciting for us.
Yeah, that does sound pretty exciting. And so what kind of, you could be like, oh, your memory's degraded by 13%, or maybe go get a checkup or something like this, or what?
So let me give you an idea of what what kind of thing you can expect. You come in, we make the measurement on your brain, and then we could see certain parts of your networks are not quite balanced in a way that it's optimally functioning. So it'd be like, oh, to give you a real example, for a certain subject, we were like, oh, this person probably has memory disruptions, has anger management issues, and anxiety issues. And these were things that we could pick up in the brain scan. And the subject actually denied that he had these problems. But for example, the family member who was with the subject was like, actually, you have those problems. And it is very interesting. This was not in a case of a very severely ill patient where we can pick these up in a very interesting manner where sometimes we can even, a lot of us are not very well aware of what problems we're having because we're trained to ignore our problems because we're very busy. We have to live up to all of our expectations at work and as a member of society where we try to ignore problems. And so sometimes, not on purpose, we don't really know what some of the problems we have are, but it is the brain scan objectively shows us the network activity, which allows us to pick that up. And so the way I envision it going forward is that we design the solution to be something that's very helpful for patients who actually need care, where you define the network problem in more detail so that you can help guide treatments for seriously ill patients. But what we are also finding is that it's useful for many other categories of subjects, which is one, there are a lot of us who feel like something's not quite right, and you go through tests and the tests all come back normal because the tests are not sensitive enough to pick up the issues. And sometimes if you are very sick, you still manage to get a diagnosis through surveys and whatnot, but that doesn't give you a path to treatment. And it's also non-objective, which is a problem. But that is the set of patients who could now start to objectively visualize the network issues. The other category is like you and me. We all have our ups and downs in our brain's performance. And by being able to visualize your brain status in a more objective number, like we measure our blood glucose level or our weight, you can start to optimize your own performance and also do preventive care.
Yeah, that's pretty exciting. Yeah, maybe be able to quantify some of these things that have been unquantifiable until now. So EEG is a pretty coarse way to do measurements. It has to go through the skull and scalp and everything like this. So the signal's quite attenuated. You can only pick up very large groups of neurons. So I guess how many channels are you guys using? And then how accurate is it? I mean, if you had better fidelity, do you think it would be even better, or is it pretty good so far?
So that's a really good question. EEG is notorious for its noisy signal, and it has had limited use partly because of the noisy nature of the signal. We decided to try to extract information from EEG because of the ease of deployment, where if it was, for example, only doable with an MRI scanner, that's much harder to deploy than an EEG system, both in cost and siting. And so the choice of EEG was not because EEG has the best signal, but choice in EEG was to try and have a solution that could help as many people as possible. And what we use in terms of channels is a standard clinical EEG, a 1020 system that has 19 channels. And of course, if we had a much more detailed information from a larger number of channels or even more invasive methods or a larger scale equipment, which we are not excluding for certain applications, we are using those. But what we wanted to first do was to see how far we can go with EEG. And we're very excited that we can actually go pretty far and enough that it could make a difference in the current clinical care. And despite the fact that EEG has quite a notorious reputation, we are able to pick up very interesting information for two main reasons. One is that we've spent a lot of time. For this, we utilized machine learning to really clean out the signal, to pick up within the noise, find the signal that has meaning. And also because we've spent very significant time trying to understand how the brain works so that we can also selectively pick up those information from a very noisy set of data.
Yeah. So does that mean you have to have more data in that case? And I guess how big of a population size did you build off of? And how did you know, like, how did you find that memory degraded person and put them in that category, for example?
So we've used quite a large set of data, which is why it took a very long time. This work is 10 years in the making. And so it's been quite a long journey, but because of the relentless effort, both cleaning the data, like drawing insight from large data, and also from basic neuroscience, we were able to pick up these signals. And it's a decade-long process where I won't say like it was easy, but we're very excited that it's possible now.
Do you think you could even discover new indications or diseases or something like this that
Oh,
wasn't?
actually, we are in the process of discovering new things almost every day because of the fact that, like, before in our development, we only utilize very clinically well-defined data sets to understand what sort of problems the brain was having in general. Sometimes, because of the fact that we are looking at individual subjects now, not defining a population and just these are like memory disorder patients, these are not memory disorder patients. Instead of doing that, we're seeing like individual variations, and this person has this type of memory dysfunction, which is very different from other people. Sometimes, for example, certain patients have unknown cause memory disorder, and these things are all categorized as unknown or lumped into bigger things. But when we start to look at individual subjects' data, we're starting to learn that the disease is much more diverse and has causes that are unexpected, but interesting to see that now that we have technology to visualize them.
Yeah, exactly. Yeah, speaking of technology to visualize, EEG has been around for a century or something like that. Why hasn't this been done before? Is it just you need lots of compute power to be able to do this, or what?
It's multiple factors. It requires better hardware. It requires better signal processing capabilities. Key thing is also it requires like very in-depth circuit knowledge, which didn't exist before. And so all three categories are technologies that are just only now available. The really interesting part about it is that despite the fact that we could find all these things, because of its notorious reputation to date, a lot of people who are well versed in EEG are like, you can't really pick that up. And then they come and have an exam themselves and they're like, oh, that's possible. And so, yeah, never say no to something that you haven't seen before.
Yeah.
I
Wow.
mean, that's a lot of, it's generally true for all technology. Would people have believed that we could make these cell phones do all kinds of things that we're able to do now? The human history of technology development is always pushing the boundary of something people think is not possible. And with EEG in particular, there's been a lot of reputation around it where, that's not possible. But it is where we are able to see things now. And so we're very excited. And seeing is believing. That's why our motto is also see the invisible. And once you can see problems, those are solvable problems. That's also the general philosophy I have regarding anything scientific. Things you cannot put numbers to or see are problems you can't solve. Whereas once you can see it and put numbers to, they're all solvable, is my general thought.
Yeah. That is definitely like you can, and then you can improve it too, right? You can get that number up and be able to do this. So, do you have to do it over a longer period of time? If the signal is coarse and not very clear, and then you have to have the computers be able to decode that longer. Do you have to do it for a longer time? And then I don't know if we talked about your clinics and what role does that play in everything?
Yeah, so because we've spent all that longer time for you, each subject doesn't have to spend a longer time. We actually, in fact, can infer a lot more information from a shorter scan. Of course, longer data always gives us more information, but compared to what you can do right now as a clinical standard, we can pick up a lot more from a much shorter scan. And so it actually not only allowed us to pick up more information, but also from a shorter time. And speaking of clinics, the Novera Brain Health Institute was established as a way to deliver this new kind of accessibility to patients in a different model from what is currently available in the standard of care. For neurological care, there are two camps largely. One is a more local clinic or primary care. The other is large hospitals. They support very different kinds of patients. What we wanted to do was to really establish a clinic that can do health checkups for you, even if you're not sick. All of us, even when we're not sick, as I said, we have ups and downs in our performance. And also, we're all aging. And after about 40 or so years of use of your brain and highly stressful environment, we find that above 40-ish, a lot of people have brain functions that are non-optimal. And so we wanted to provide a more accessible platform for someone who doesn't really perceive yourself as a patient, that where you won't go to big hospital neurological care, then you would be dismissed actually because you look fine. And then also in a lot of the local clinic settings, some of the really high-end data acquisition and analysis is not available. And so we're providing a very accessible clinic platform where you can go in and do tests. Also, if you're like a really seriously ill patient, we help support those patients by supporting surgical decisions for big hospitals, but also for primary care. Let me give you an example where one patient, he was a cancer patient and did not really get any neurological care because he was a cancer patient, but he had extreme pain that he couldn't tolerate, and he contacted us because they heard about us. And then when we tested him, we found out that because of he had 20 something chemotherapy. And after these extensive chemotherapy, his brain actually was quite damaged from what we can tell in our tests. But because of the fact that he was categorized as a cancer patient, not a neurological patient, and also neurological care is very difficult to access, even for primarily neurological care patients. And so by having this clinic platform that really focuses on easy access neurological care with state-of-the-art information, we want to also directly deliver a higher standard of care to the patients directly, but also support existing healthcare infrastructure by helping like primary care and also supporting complex procedures of a big hospital.
So EEG is quite approachable and easy to do, right? Do you think your clinics do a better job placing it in the right location, or could somebody place it on their own or something like this and be reasonably good? Or do you think you guys do you get better data with the clinics?
So that's a very interesting point. You just said EEG is very approachable, but if you want to get a clinical EEG right now, where would you go? You cannot get one because you're not that sick. There's a long wait list for people who need to get EEG. And so it is actually not approachable at all. And there's a huge wait list. There's care deserts for people who are known to need EEG, like epilepsy patients or sleep disorder patients, which is mostly what it's used for right now clinically. And so the accessibility is actually a huge issue. And by having these very easy approach where we have automated a lot of things with AI. And so now if you go and get an EEG in a clinic, it takes like 1 week for someone to get back to you, even after waiting many months to get the exam. Our solutions are fully automated. And so we could technically return the information back in real time. And so because of the fact that we have innovation in both placing the electrodes and then delivering it, but also automated processing and more information access, it actually really changes how we as all individuals have access to it. I myself get my brain checked out regularly in order to monitor how my stress level is impacting my brain and things like that, where I learn something every day, even just looking at my own brain. And so it is if we didn't have this clinic or this technology, is there a way for me to do that? Actually, no.
Yeah, interesting. I didn't know that. I thought that it was I didn't know that it'd be a wait list because essentially at the end of the day, it's just putting gel things on your head, right? So there shouldn't be any bottleneck for that. But
Spoken like a true scientist, where in order to actually clinically deliver that, you need a trained technician to put that gel on the head, which alone has huge shortage throughout the nation. And being able to have that technician, being able to have a physician who can do the interpretation are both in huge shortage. And unless you're a very ill patient who is waiting for that, you walk in and say, I have a headache, I want to get an EEG, like no way on earth you will be able to get that.
wow, crazy. There are EEG companies though. Have you thought about partnering with them or yeah, what does that look like?
Yeah, we partner with a lot of different companies, but our key technology is that we have a fully automated processing platform as well as the digital twin technology.
Okay. And so you're a software as a medical device, and that's a pretty new designation. So how does that work, and how do you also prevent from somebody relying on it too much? Maybe a doctor. How do we keep the doctor using his brain?
Right now, it's very hard for the doctors to actually concentrate on the diagnosis and care of the patients because a large amount of data is manually processed. And as you're fatigued, it's very hard to do that. And so it's not so much that we prevent the doctors from using their brain, it's really helping the doctors to really only use the brain on parts that we want the doctors to use their brain on. And so it's really bringing the neurological care more into the current century. The way it's done is pretty archaic right now. And so that is a more of a accurate description of how this interacts with the doctor. All healthcare, primarily the responsibility is with the healthcare professional. And so we provide with the best information that we can, and it is delivered through the decisions that the healthcare provider makes.
So is this like a dashboard that a doctor might have, or some kind of lab or something like this? Or I guess what does it look like too?
It's a web-based software that allows you to just log in, very easy access with full security, where you can just get all the information you want quite easily without going through layers and layers of different software manipulations.
And then they upload it, it calculates it on the cloud or something like this, or?
Yeah, it's automatically uploaded and then it's automatically calculated. Once data in, all the results are out and you can review everything inside the platform.
Yeah, that's exciting. So you started this after you said 15 years of research. Was it all at Stanford or was it in different places too? And what was that business creating process like? I think it's partially a requirement of Stanford professors to have a startup as well in the Bay Area and Silicon Valley. But what was that like? And any issues with that, or what did that look like?
Yes, I want to tell you a brief history of why I ended up doing this. I am actually trained as an electrical engineer. My PhD was in electrical engineering from Stanford. And around the time I finished my PhD, my grandmother had a stroke and she ended up bedbound for 12 years doing rehabilitation for stroke. And then she passed away at the end of it. And seeing her go through that was my first like entry into, oh my God, brain disorders, bad. And there's very little people can do about brain disorders. And so that's around the time I finished my PhD. And so I just switched my research like 180 just out of nowhere into neuroscience after finishing my PhD. And what led me to do that was understanding that, oh, the brain is a circuit, it's an electronic circuit. And if it's an electric circuit, why don't you just analyze how the circuit functions? That way you can diagnose the problem. If there's certain functionality missing, you can restore it. Why don't we do that? And I didn't get a good answer from anyone regarding that. So I was like, let me try doing it myself. And so after I finished my PhD at Stanford, I was hired as an electrical engineering professor at UCLA. And so I had just moved to becoming a professor in electrical engineering at UCLA. But because I switched my research abruptly, right as I was hired as a professor, and so in order to support my new research, I also had to find another job. And so I ended up coming back to Stanford as a professor. And so this research is something that I've done starting at the end of my PhD at UCLA and also at Stanford. And then this effort from the beginning, when I started neuroscience, was not really, let me do this research and publish papers. It was more about, I really wanted to help the patients. And so publishing papers doesn't quite do that. And so from the beginning, that's what I wanted to do. And once we started, there was some technology that we developed in the lab that started to show like mechanisms of circuit function, the way I was envisioning it. And then once it started to take place where I was starting to see clues of how the brain circuit information should be visualized, I started the company and we started implementing it for clinical use. Like delivering a clinical solution has many barriers, like FDA and security, the need to raise money to make it happen. Lots of hurdles, but what's important is that we're there now where we're starting to be able to deliver the solution. And so lots of challenges, but very exciting that we're finally there.
Yeah, wow. That's a heck of a story. And it sounds like you're able to manage it all. So, where do you hope to be in 5 years? What do you think? Where do you hope that where will he be singing?
Recently, there were some articles out about how for even traumatic brain injury, as it is dramatically increasing, funding is cut by 75% over the past 3 years or something like that. And funding for research is important, and it has been a very important way that we have been making all these advances. But at some point, I think we need to start delivering solutions, which is one way of ensuring that we as a public, we continue to fund. And for brain disorders, it has been a very disappointing road over the past few decades. Even though scientific advances were made, the practical solutions have not been delivered sufficiently for patients who are suffering. And now that we have these solutions that are clinically applicable today, in 5 years, I really hope that brain disorders change the concept of brain disorder to change where right now, if you have some problem with your brain, you're basically a disabled person and there's no hope. But I think what we can hope to get to in 5 years is where brain is something you can maintain, right? You just like your car, you change your engine oil, you kind of maintain the status of optimal performance rather than you just use it to the max and until one day it stops working and you're disabled. So that is my hopes and dream in the next few years where we can start to change how we think of brain disorders.
Yeah, hopefully. That'd be great. And you think Elvis will be able to do that with more accessibility to EEG? And do you think that'll open the door?
Absolutely. We're already starting to see a patient getting better. And there are some patients that were treated at Novera Brain Health Institute based on the network information. These were patients who have had no other solution to treat. And now that we're able to see things, the outcomes are quite exciting. And so here and now today, of course, not all brain disorders, but many disorders that were very difficult to treat we're starting to see changes. And so we're very exciting that now is the time and it will start to dramatically change the course of brain disorders over the next few years.
Yeah, that's exciting. Cool. Well, Dr. Lee, this has been great. Is there anything that we didn't talk about that you wanted to mention?
Thank you very much for having me on your show. It was very exciting and hope to see you guys all again soon.
Hope you enjoyed the show and were able to learn something new, bringing together different fields in novel ways. Until next time on the Neural Implant Podcast.